All right, so we're looking at quotient rule. Let's look at quotient rule. All right, let's see how we can apply quotient rule, differentiation, the method of quotient rule in differentiating functions. Now, we have if y is equal to tan x, find the y dx. All right, now the thing is, we are given that y is equal to tan x. Where do you use quotient rule? You use quotient rule when you have your function in the form y is equal to u over v. That means there's a numerator and there's a denominator. All right. Now, so the thing is, you're going to recall, all right, that y is equal to tan x, right? Y is equal to tan x. And also recall that what tan x itself, from here, we recall that y is equal to tan x. Tan x itself is what? Sine x over what? Cos x. All right. So now it means that what? That I can still write this as y is equal to what? Sine x over cos x, which now makes this now to be in this form. All right. So this is my u and this is my v. Now, the numerator is always your u and the denominator is always your v. Now, what's the formula for what? For quotient rule. The formula for quotient rule, all right, says that what? The y dx is equal to what? V du dx minus u the v dx over v squared. All right, over v squared. So this is the formula for quotient rule to find your to differentiate or to find your dy dx, all right, or to find derivative when it's a quotient, all right. So now y is now a quotient. That's sine x over cos x. That's the numerator becomes our u, the denominator is our v. So we have what? U is equal to what? Sine x, and then we have that what? V is equal to what? Cos x. So we're going to differentiate this out. We're going to differentiate it out. So differentiating this out, you have du dx is equal to what? Cos x. If you differentiate sine x, you're going to get cos x. So differentiate this side, dv dx, we're going to have what? Minus sine x. All right, minus sine x. All right. So now putting this, now we have everything we need into this formula. Don't forget that the y dx is v du dx minus u dv dx over v squared. All right. So following this formula now, following this formula here, now it becomes that what? The y dx will be equal to v du dx, v du dx. Now v is what? What is our v? Cos x multiplied by what is our du dx? Our du dx is also what? Cos x. Now minus, there's a minus here, minus into bracket u dv dx. What's our u? Our u is what? Sine x. All right, multiplied by what is our dv dx? All right, our dv dx is what? Minus sine x. All right, so this is going to be over what? V squared. What's our v? Our v is cos x. That's cos x all squared. All right, cos x all squared. So now let's continue. All right, so we followed this formula and we have this. So let's continue. Now we're going to have it that what? We're going to have it from here. All right, continuing from here, we're going to have it that what? The y dx is equal to cos x times cos x, of course, gives us what? Cos square x. Now sine x times minus sine x gives us minus sine x. All right, sorry, minus sine square x, sorry, all over what? Cos x all squared is cos x times cos x. That gives us cos squared x. All right, now the y dx is going to be equal to what? Now this minus, there's a minus here, sorry, because sine x times minus sine x gives us what? Gives us minus sine square x. So this minus x gives us plus. That's cos square x plus sine square x divided by what? Cos squared x. All right, so now this is going to be what? The y dx is equal to, I can also write this cos square x plus sine square x as the same thing as sine square x plus cos squared x all over what? Cos squared x. Now recall, all right, I want you to recall from your trigonometric identities that what? Sine square x plus cos square x is equal to 1. All right, so it now becomes that what, that anywhere I see sine square x plus cos square x, I put it as 1. All right, so this becomes what, dy dx is equal to what, 1 all over what, cos square x. All right, and I want you to recall, all right, recall that 1 over cos gives us what, sec x. All right, from trigonometric identities. All right, so it means that since we have 1 over cos square x, in this case finally our dy dx is going to be equal to what, is going to be equal to sec squared x. All right, sec square x. All right, that is why when you differentiate tan x, all right, you get what, that's why when you differentiate tan x, you get what, cos sec square x. Sorry. Now, so this is our answer. All right, so when we differentiate tan x, we get sec square x, and we use what, quotient rule to get that. Make sure you like this video, share this video, and hit the subscribe button, and watch more videos on this.